Hello and welcome to the second part of Python standard library discussion. So we continue from our previous discussion on built-in functions. So let's get started. One of the built-in functions is byte array. It takes a source, encoding and errors. So if it is a string, we must supply an encoding and optionally errors. Now if it is an integer, the byte array will be of that size and the initialization will be with null bytes. If it's a string and we supply an encoding, then byte array will convert that string into bytes using str.encode function. Now if it's an object, then the object must implement the read-only buffer from the buffer protocol. We will talk about buffer interface later on, so for now we can just notice this. And if the source is in a table, then it must be in a table of integers in the range 0 to 256. That is this range. It should be half open, half close interval of 0 to 256. The reason is that a byte cannot represent value more than 255. And without an argument, if you give nothing, then array of size 0 is created. Obviously, there will be no value in that. For example, here I have used ABCD, so it will just print the ASCII value of ABCD because ASCII is our encoding. In case of UTF-8, it will convert the UTF symbol to bytes, and in case of UTF-8, this will convert ABCD to bytes, but actually ABCD turns out to be ABCD in this case because they have the same value in UTF-8 and ASCII. Now in case of 9, it will print a byte array of 9 values, each initialized with none. And in this case, we have shown that you can initialize it with a list and it will have the same value. So if we run this program, we see that in our last case, it prints the hexadecimal value and others are same. The difference is this is a string, but this is a byte subject. That's the difference. That means their type is different. Although the content is same, the type is different. Now in this case of registered trademark, it has the Unicode equivalent in form of bytes. There are some interfaces of certain programs use strings and some libraries will use bytes. It depends. For example, a password hashing function will take a string as input and produce bytes as output. Many cryptographic functions will take string as input and produce bytes as output, and then vice versa for decoding and so on. So let's move on from this. Next is bytes. Now bytes is an immutable version of byte array. That is, this byte array could be modified, but what bytes will give will be immutable. So it does not give an byte array, but it will give you the bytes of that. So now if you see, it does not give an array, it gives an absolute object bytes which is immutable. So it is similar to in behavior to byte array. Now we come to callable. So callable returns true if the argument can be called or the argument is callable. This was introduced in Python 3.2 plus. So we also comment out this because this will cause an error. So in this case,
Sorry. In this case, int is callable because int is also a function which converts arguments to integer or tries to convert an argument to integer. Callable is our class which has implemented call interface. All classes are callable because when the classes are callable in an instance, but an object is callable only if the class implements underscore call underscore. So in this case, for the third one, we need to implement this function. Let's see that how it works. So let's see how it works. So in this case, it returns true in each case because all three are callable. Now I should try this with a value like x is equal to 5. It will not work. It will give an error. So, oops, we'll have to use this here. So in this case, it will print false. Let's move on to next function. Now, CHRI will return the string representing a character whose Unicode or ASCII value is given. But in Python, there is no ASCII string, all are considered Unicode. Now, the volume range for I will be 0 through 1,114,111, that is 0 to 10 FF in hexadecimal. And if the argument is greater than or less than this, then an argument exception will be raised. So 65 is A, and these two have some Unicode symbols. I don't know what those. So let's see. So this is something looks like lambda or something. Inverse lambda. Looks like an inverse lambda to me. This is some except on R. 45. So that's what CHR does. And opposite function to CHR function is odd, which will take a signal and we produce an integer. So now we come to class method. The class method is one which can operate on class. It does not need an instance. So it's a decorator. The function will receive CS instead of self, it will receive the CS, that is, it receives the class. So we can enroll this on the class A.f here, and we will execute the class method. So it says I have a class method. So sometimes the class methods are useful when we are writing libraries and all that. Now we come to the next one, and this one is a bit complicated. Not necessarily useful all the time, and there are these examples where it will be useful. So this function is called compiling. It takes a source. Source can be a normal string, a byte string, and AST object. AST means abstract syntax string. The file name from which the code can be read. If it is not a file, a name can be given, or you can simply give empty string. The mode can have three values: exec, eval, or single. So eval is source is single expression. Exec means multiple expression and statements, classes, function, and so on. Single means a single interactive statement. Now the flags don't inherit. Okay, the default values are 0. So it is used to import values from features of Python. That is something which is not yet in the standard library, but you want to implement them into this. Now we see this in discussion when we will discuss features and so on. And optimize is the optimization level of the Python compiler. The default value is -1. So in this case, we take the string x is equal to 7 backslash 7, y is equal to 10 backslash 7, sum is equal to x plus y, and print sum. So we pass this code string to compile function. Our file name is empty string, and we pass this through. We use the word exec because we have multiple statements and expressions, and then we try to print the code object itself, and then we exec. So let's see what it prints. So sorry, I'm not saved. So in this case, the code object is actually a code object, and it is defined at level and so on. But when you execute this, it evaluates this. It prints the sum as 17 because 7 10 will be 17. So it prints this value. So it can be useful, like you can have a string template and then you can bind certain values to certain parameters in that template string, but I have not seen this being used as much as it looks like benefiting us, but it does not really benefit much. There are very niche cases where you can use compile to actually control the execution of a program. The reason is that whatever code you want to execute here, you can actually write as code. Okay, and the variables can be passed. There is no extra benefit from this. You can always expand code string or file in this. Or if it's a file, they can import the file itself, which will execute the alternate code, and then we can call the function and so on. So it's not really useful. You can ignore this for all practical purposes. So now we come to the last function, which is complex. This complex constructs a complex number. The first argument is the real part of the complex number, and the second argument is the imaginary part of the complex number. We can also use the string form, in this case, that is a plus bj. Now there should not be any space in the string, and also if you use the string form, then the second argument must not be supplied. If you have space, it will be invalid, and if you supply a second argument, then it will throw an error as well. Similarly, a class can return complex by implementing underscore complex and underscore. Or if it does not implement this function, it can implement underscore float underscore. Or if it does not implement either complex or float, it can implement index function. So if one of these three functions are there, then the complex can be applied on that object. So here we have defined the underscore complex underscore and create an object of x, and then we try to initialize a complex number with that. So let's see what is the output. So in first case it printed 1 plus 2j, in second case 3 plus 5j, and in third case it prints 4 plus 5j. So if you change this to, for example, again, in this case also, you will get the same output. Now it returns okay. So I think this will work. If I remember it right, the float should have worked, but let's try index function, if that works or not. Oh, this also does not work. Okay, I will verify this and I will make sure that I clear this up in the next video, because if from my memory I can say that float and index should have worked, but it seems that they do not work, so we need this to be complex. So this is 4 plus 0j. We can make this 5j. I'll clear this up in the next video. So that's all for this video, and thanks a lot for watching. If you have found this video useful, and if such is the case, then please subscribe to the channel and like the video so that more people can benefit it, because when you like the video, YouTube ranks the video hard, and more people will get to see the video in their search and all that. And thanks a lot for watching.